Hello everyone and welcome back to my SP2 channel. This video is all about the reaction stoichiometry, which is a very important topic for chemistry. We're going to be talking about this concept in depth today, and we also have a practice for you at the end. Okay, so let's start by kind of introduction to our reaction stoichiometry. So think about a chemical reaction. When a chemical reaction is carried out, it is always important to understand how much of each product will be produced or even how much of each reactant will be consumed, right? Because this would allow us to calculate the exact amount of reactants needed to avoid waste or even shortages. It helps determining how much of a desired product can be obtained, which is very important in manufacturing, in pharmaceuticals or even other industries. It also helps preventing dangerous excesses that could lead to an accident or maybe an explosion or harmful byproducts. Okay, now a quick reminder for you: the coefficients that we use in our chemical equations indicate both the relative numbers of molecules as well as the relative numbers of moles in our reactions. Okay, so let me expand this on the next page. So let's say we have this reaction, which is hydrogen and oxygen gases that are reacting and they're producing water. When you balance your reaction, you have 2 for the coefficient for hydrogen, right? There's only 1 for oxygen, and we also have 2 in front of water, right? So I can say that either the 2 molecules of hydrogen gas reacting with 1 molecule of oxygen gas to produce 2 molecules of water, or I can say 2 moles of hydrogen gas reacting with 1 mole of oxygen gas in order to produce 2 moles of water, right? So keep that in mind. You always can use these coefficients for both molecules as well as moles. Now, a little bit more kind of expansion on that. Follow me on the next page. So you're still having the same reaction, right? Remember we said we can think about these coefficients as molecules. So if you look at your molecular interpretation, you can see that we have these two, white clouds, right? Presenting the hydrogen molecules reacting with a red cloud, right? Which is our oxygen molecule to produce these two molecules of water. If you look at your mole interpretation, right, you can say 2 moles of hydrogen gas reacting with 1 mole of oxygen gas to produce 2 moles of water. And as you can see, if you look at what we have on the reactant side in terms of the molecules or moles, it's not necessarily the same as what we have on the product side. But if you actually look at your mass interpretation, right, then you can say we have 4 grams of hydrogen gas because we have 2 moles. We have 32 grams of oxygen gas because there's only 1 mole. And when you sum them up, that must be equal to 36 grams, which is exactly what I have for water, for 2 moles of water, right? So the masses must be always equal, which is exactly what we have for the law of conservation of mass. Okay, now for any given balanced reaction, if the mass or even the moles of one reactant or one product are known, we should be able to calculate the mass or moles of any other reactants or products, right? As long as we have the balanced reaction. So I'm going to summarize these in 3 steps for you. The first step is, let's say the grams of substance A is given. You can use molar mass of A, right, from the periodic table, and you can calculate moles of substance A. Then, looking at your balanced chemical equation, right, you can figure out the coefficients from that balanced equation, and you can calculate the moles of the other substance. I'm going to call that substance B. And then the last step is using the molar mass of B to calculate the grams of B. Okay, so to make even more sense of that, I'm going to have a really good practice for you on the next page. Okay, so here it says determine how many grams of water are produced in the oxidation of 1 gram of glucose. The glucose chemical formula is given here, which is C6H12O6. And the term oxidation in this question is pretty much referring to the reaction with the oxygen gas. So that means we are looking at a combustion reaction. And we have learned from our previous videos, right, that the combustion reactions is going to produce carbon dioxide and water, okay? And you also know how to balance the reaction. So we must be able to write the reaction and balance it out. Okay, now, remember our map? I'm going to start by step number 1, using grams of the sugar, okay? And I need to calculate the molar mass of my sugar. So you have access to your periodic table. You can figure out the molar mass for this glucose, which is going to be 180 grams per mole. Now, when you try to set up your calculation, you want to make sure that whatever is this unit, right, this is grams of sugar, it has to be consistent with the unit that we have in the denominator. So I can cross them out, okay? And that means what I have at the moment is moles of sugar. Okay, so I'm done with the step number 1. Follow me on the next page. Now looking at your chemical reaction, which is already balanced, we know that for every mole of sugar, we are going to produce 6 moles of water. So my coefficient here are going to be 6 on the top, right? 4 moles of water and 1 mole at the bottom for my sugar. And again, you have to be consistent that these two, right, must be always the same so we can cross them out. So what I have at the moment is moles of water. I would stop here if the question was asking about moles of water. But because I'm looking for the grams of water, I'm going to take it to the next step. Okay, on the next page. Okay, so here is my last step. I'm going to use the molar mass of water, which is 18 grams per mole. And again, I got this from the periodic table. And I'm going to have these two consistent, so I can cross them out. So what I have at the end is grams of water, which is exactly what I'm looking for, right? So when you're looking at this, what I call the train, right? What you're looking for here must be exactly the same as the unit that you have at the end, okay? And then you can just plug in the values, right? Do the calculation, and that is going to give us 0.6 grams of water. Okay, excellent. Thank you very much for watching this video. If you found this video helpful, please don't forget to give it a thumbs up. You can also share that with your friends, right? If you're enjoying the content and you want to keep learning with me, please subscribe so you're not going to miss out any of our future videos. I would love to hear from you guys. You can drop a comment below if you have any questions, or maybe there is a specific topic that you would like me to cover that in our future videos. Your support means the whole world to me, and it really helps this channel to grow. Thank you so much, and I'll see you on the next one. Take care and bye for now.